Greetings and welcome once again to my new calculus channel. My name is John Gabriel. So we're having a discussion, or some people are having a discussion on the new calculus Discord. And this contributor says that people have been telling me that Euler's book is more or less the same as mine. Well, it's not exactly true because although Euler knew a lot of things, he did not get the basics right. So let's look at Euler's main textbook, which, by the way, I've forgotten because I first read it when I was a teenager. But looking at this, in fact, I was under the impression that it was written by Wallace, and somebody corrected me and said, nope, it was written by Euler. So, yes, and now I remember. Now, let's look at what he says. He says, whatever is capable of increase or diminution is called magnitude or quantity. Now, if you think about that statement very carefully, you'll realize you can't have negative numbers, okay, or zero even, okay. So uh, yes, we can modify that so that we can have negative numbers, make sense of negative numbers, and also of zero as a placeholder. So then he says the sum of money, therefore, is a quantity, or rather, I would say a magnitude, not a quantity, but they mean the same things, don't they? If we go to Google and we say define quantity, let's see, it says the amount or number not usually estimated by spatial measurement. So it means it's probably not uh, measured by number. Okay, so anyway, let's not waste time on that. He says from this definition, it is evident that the different kinds of magnitude. So now he switched on to the correct word. So here you see, he did use it initially, I'm sorry, but he should have been consistent in using one word. So must be so various as to render it difficult to enumerate them. But what does that mean? How do we enumerate magnitude? Well, you can't enumerate magnitude unless you put it into comparison with another magnitude, right? Which is what I've always been saying, is that you need a ratio to begin the realization of number, okay? So I think Euler got this, which has always surprised me, by the way. And this is the origin of the different branches of mathematics. In fact, it's the origin not only of mathematics, it's the origin of all STEM and every other knowledge that humans have, each being employed on a particular kind of magnitude. So a particular kind of magnitude. Well, and as we know now, it doesn't just have to be one magnitude, but in the beginning, it's important that the magnitudes are homogeneous. So Euler says mathematics in general is a science of quantity. I say mathematics is the abstract science of measure and number. But I suppose that's pretty close. Now, we cannot measure or determine any quantity except by considering some other quantity of the same kind as known. Yes, of course. That means you need a ratio, doesn't it? What does that mean? Isn't that what the great mathematician Euclid wrote in definition 3 of book 5? Yes, he was describing this and pointing out their mutual relationship. In other words, do they have quotientness? Because in order to enumerate them, as you see over here, they need to have quotientness, right? That's how we find out their particular kind of relation. And if it were proposed, for example, to determine the quantity of a sum of money, we should take some known piece of money, such as a louis, a crown, whatever, and show how many of these pieces are contained in a given sum. Exactly. Okay. That's where you get number. But you have to build up natural numbers first from ratios of homogeneous magnitudes. So then he continues and he says, so that the determination or the measure of magnitude of all kinds is reduced to this: fix at pleasure upon any one known magnitude, yes, a unit, say, of the same species in which it is to be determined, and consider it as the measure or unit. Absolutely. I totally agree with that. Okay. In other words, you can choose any one you like. It doesn't have to be a particular one. But what one can understand there is that that's not a physical unit. It's an abstract unit. Okay. So, for example, in geometry, you have a ratio where this consequent acts as a unit. Okay. And it matters what type it is because you're dealing with line segments here. Okay. You're dealing with line segments. But if you're not dealing with line segments and you're dealing with something else, then the unit is uh, no longer a physical unit. It's an abstract unit. If you say 3 apples, okay, that means 1, 2, 3 apples compared to an apple. Okay, so the unit here is an apple. It's no longer a line segment. So this is actually even 2 levels above the number abstraction level, because when you define numbers, you say, okay, let the measure of that ratio be the unit, and the measure of this ratio be 2, and so on. So you name them, okay, because that's 2 1, that's 1 1 2 1. And how do we get that 1 1? Well, this is 1 1, right? 2 1. But we first define this in this way as 1 over 1 and 2 over 1, and then we know that's how we're going to enumerate the parts of the ratio later on. So then he says, so that a number is nothing but the proportion of one magnitude to another arbitrarily assumed as a unit. And guess what? That rules out 0 as a number, okay? Because 0 cannot be in proportion to any other magnitude. Did you get that? Stop the video and think about that. And then he says, finally, from this it appears that all magnitudes may be expressed by numbers, and that the foundation of mathematical sciences must be laid in a complete treatise on the science of numbers. Blah, 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 blah. Okay. And then he says, in algebra, we shall consider numbers which represent quantities. All right, I'm not going to read all that. I just wanted to focus on that first part. So if people say I'm similar to Euler in this respect, yeah, maybe I am a little bit. Perhaps I am. But Euler goes way off track later on in his elements. Okay. He doesn't define number in a 100% rigorous way as I do. And you can find the way I define number if you read my articles. Okay, and I'll place a link to one of the articles. Euler wasn't a bad mathematician. He was quite good, actually, and I'd say his Elements of Algebra would have been a great textbook if he didn't make so many mistakes. Okay, which he did make later on. I mean, saying things like infinity equals to 1 over 0 or 0 equals to 1 over infinity is total garbage. I mean, he starts off saying things and then he contradicts it in statements like this. Absolute drivel. Okay, so he just goes ahead and does whatever he wants to do later on, totally ignoring and contradicting himself as to what he said in the beginning. Okay, so how do you realize number? Realization and development of number in one page. I shall place a link to this so that you know how to do this, because it's pretty important that you know how to use numbers. I mean, after all, numbers constitute algebraic measure, okay? And if you're wondering how the Greeks did it, well, they didn't use numbers, okay? They used ratios, as I explain in this brilliant, never before revealed article, Arithmetic without numbers. Of course, it takes genius to realize this stuff, and I'm sure that the ancient Greeks knew this, but guess what? They didn't write it down. It's not written down anywhere. Try to find it, okay? Here's a challenge to you. Try to find this method that I described to you anywhere else in any published text. I challenge you to do that. You will not, because, well, I'll tell you what, if you do, it'll be a shame, because it'll make me look like a liar, and I have never actually copied anyone else's thoughts. I have my own mind. I have never read things that others have written and taken them as fact, and neither should you. Even the things I say should be investigated, because I'm human and I can make mistakes. But I don't think I've made any mistakes. And if you read my works here, you'll see that it's the work of an absolute genius, okay, which I am. And I'm not ashamed to say that. Now, that's pretty much it. If you're not already a subscriber to my channel, become one. and follow me on academia.edu. Till next time, goodbye.